Problem 14.12 involves a system of three identical 19.32 pound particles A, B, and C. I'm going to call that W, which is equal to mg. The velocities of the particles are respectively v sub A equal to v sub aj, v sub B equal to v sub I, and v sub C is equal to v sub ck. And the magnitude of the linear momentum of the system is 9 pound-seconds. Knowing that h sub g is equal to h sub 0, where h sub g is the angular momentum of the system about its mass center g, and h sub o is the angular momentum of the system about point O, wants us to determine A, the velocities of the particles, and B, the angular momentum of the system about point O. So, first of all, the definition of angular momentum about point O would be the summation of the r sub I crossed into m sub I v sub I. We're told that that's equal to hg in this problem, and hg is the summation of r sub I prime crossed into m sub I v sub I r v sub I prime, as proven in the textbook. When you expand this right here, let r sub I prime be equal to r sub I minus r bar, and then cross that into mv sub I. The r sub I crossed into mv sub I gives you this right here, okay? And then the r bar crossed into this is going to leave you with a summation over m sub I v sub I, which is just mv bar. So you're going to end up with minus r bar crossed into mv bar. Well, since this term right here and this term right here are equal to each other because HO and HG are equal to HG, then that means that R bar crossed into MV bar must be equal to 0. So if we expand that, then R bar, we're going to write that out for the center mass. If you look at the positions for the I direction, there's two particles that have I components. One's at 2 foot and the other one's at 1 foot. So that gives us 3 foot altogether. I'll explain this 3 out here in a second. And then you look at the J parts. Two particles have J parts. There's 2 foot and a 4 foot. So that gives us 6 foot right there, J. And then there's two particles that have K parts, and they're both 3 feet. So that gives us a 6 right there. And then that's going to be crossed into m sub I, v sub I. The masses are all identical, so they cancel each other out. And R bar then from right here, let's see, R bar is right here, R right there as well. MV bar then, the M's all cancel out, since it's all equal to 0, they're going to disappear then. And we're going to have V bar, V sub B times I plus V sub A times J plus V sub C times K, and all that's equal to 0. The 1/3 right here is coming from the fact that when you calculate R bar, remember it's total mass times the position of the center mass is equal to the individual masses times their positions. And so that gives us and since R bar is the sum of the m sub I and r sub i's, and each one of those masses on that side is going to cancel out with one of the masses, but the total mass is 3m, so that's why the 1/3 is appearing there. And the 1/3 can cancel out that 3 and makes 2, and 2 out of those 6's. So if you look at the I part of this motion and look at what you have in the I parts, you're going to have J crossed into K terms to give us an I, so that's going to give me a 2 V sub C right there. And then you're going to have K crossed into J terms going to give me that, or you can set these up in matrices and see it probably much quicker. But this is going to leave me with a minus 2 V sub A, and then that's all equal to 0. In other words, you get V sub A, V sub C equal to V sub A out of that. If you look at the J part of the terms, the J's are going to come from I crossed into K. That's going to give me a negative V sub C right there times 1. And then the K crossed into the I term is going to give me a plus 2 V sub B right there. And that's equal to 0. Or you get the V sub B then is equal to V sub C over 2, which is V sub A over 2. The K part, if you look at the I crossed into J, is going to be a K part. That's going to give me a V sub A. And then we're going to have a J crossed into I, which is going to give me a negative 2V sub B right there, equals 0, and you get the V sub A is equal to V sub Z, so there's nothing new appearing out of that one. Now let's look at the total linear momentum, which is the total mass, which is 3 of these M's times V bar. And so it's also equal to the summation of the individual M's times the velocity, since they're all the same mass as I factored that out. And we have VBI plus VAJ plus VCK. Or if we take the magnitude of this, or at least the square of the magnitude, we'd have M squared, and then we'd have a VB squared plus VA squared plus VC squared right here, and that would all be equal to 9 pound-seconds, that converted to slug foot per second, quantity squared. So you end up with this equation right here after you plug in what VC is in terms of VA and what VB is in terms of VA, and you get this expression right here. When you solve for VA out of that, you're going to get a plus 10 feet per second I into J, and then we solve for V sub B from these other equations up here, and V sub C, you get these answers right here. All right, the B part of the problem asked us to find the angular momentum of the system about point O. Well, H of O is equal to R sub I, summation of R sub I crossed into M sub I V sub I. So I factored out a foot out of all of these for the distances and so on. And so the R sub I crossed into, say the A term is going to be the R sub I term is going to be 3K crossed into M V sub A then. The B term is going to have, it's got a 2 feet in the I plus 2 feet in J plus 3 feet in the K crossed into M V sub B. And then the C term is going to have I plus 4J crossed into M times V sub C. You can factor out the M, of course, and have M foot squared per second here after you plug in all the units for velocities. And so what you get is the I terms here, and they come across in various places. And this is a little bit difficult to see from right here, but let's take a look at one example here. 3K crossed into M, the M's factored out again. And you got the K crossed into V sub A. V sub A is in the J direction, so K crossed into J is going to give you a negative I. And it's 10 right there and a 3 right there, so that's why it's a negative 30 then. And then there's another I term coming that's going to give you 40. And the same sort of thing across here. These can be done different ways, but when you get it all set up and squared away, you're going to end up with units of slug foot square per second, and you'll have a 6I plus 3J minus 6K.